In this lesson we're going to prove the factor theorem. The statement is that if p of x is a polynomial such that p of c is equal to 0 for some constant c, then x minus c is a factor of p of x. Conversely, if x minus c is a factor of p of x, then p of c is 0. So let's look at the proof, and we'll start with the forward direction, which is the first statement here, this one. By the remainder theorem, we know that if we divide p of x by x minus c, then p of x is equal to x minus c times the quotient, add the remainder. Since p of c is equal to 0, r is equal to 0. Think about evaluating p of c here. We get c minus c. So p of x is just going to be x minus c times q of x. And therefore, x minus c is a factor of p of x. And we can see that quite explicitly here. We have x minus c multiplied by q of x, giving us p of x. So clearly, it's a factor. Now, just coming back to this step, think about here c minus c. If we have that in there, this is 0. This whole term becomes 0. P of x is equal to r. And we're being told in this part that p of c is 0, so r would be 0. Now let's look at the backward direction. So we're now looking at this part. If x minus c is a factor of p of x, then by definition the remainder when p of x is divided by x minus c would be 0. Something is only a factor of something else if the remainder on division is 0. By the remainder theorem, this is equal to p of c. Hence, p of c is equal to 0.